Hi, welcome to the short video presentation for StopThePop, sorted Gaussian splatting for view-consistent real-time rendering. 3D.js suffers from popping artifacts during view rotation, as can be seen in this short clip. When flipping between subsequent frames of a video sequence, these artifacts are particularly disturbing. StopThePop completely removes such inconsistencies, providing a more view-consistent 3D scene representation. Visualizing the sort error reveals the underlying issue with 3D.js. The approximate global sort produces inconsistent ordering. Our hierarchical rasterizer improves sort quality significantly. We now look at depth computation in detail. 3D.js uses the projection of each Gaussian's mean onto the view direction of the camera as depth. This can result in sudden changes of ordering during rotation, which are the underlying cause for popping artifacts. When integrating a 3D Gaussian along a view ray, the result is a 1D Gaussian. Our method takes the maximum along this 1D Gaussian as depth. We propose per tile pre-sorting to improve sorting quality. For each tile touched by the Gaussian, we compute the maximum point. Subsequently, we reconstruct the corresponding ray and compute the depth as detailed before. Per tile pre-sorting reduces sort error, but clearly leads to non-negotiable artifacts at tile boundaries. We propose inserting additional resorting levels during rendering. Consider this toy example with a 1D Gaussian. For easier visualization, we only consider one tile made up of 256 pixels. The first hierarchy level is a 4x4 tile. We compute the depth as in per tile pre-sorting, now taking the center of the tile for the view ray. We insert the computed depth into the 4x4 tile queue and perform resorting. If the 4x4 tile queue is full, we take the first Gaussian and consider each 2x2 subtile. Again, we take the center ray, compute the depth, perform resorting, and consider each ray of the 2x2 subtile. In this way, we share resorting efforts between neighboring pixels. Finally, we compute the depth along the direction of the ray, perform resorting, and blend the first Gaussian if the buffer overflows. Please note that this version is overly simplified for visualization purposes. Consider our full paper for implementation details. We introduce a metric to quantify our improvement in view consistency. As stated before, popping artifacts are most visible when flipping between subsequent frames of a video sequence. Consequently, we use optical flow to warp the current frame of a video sequence to the subsequent frame, where we then use flip to quantify artifacts. As can be seen, flip is much more reliable compared to a standard mean squared error. Our method attains lower flip scores, which indicate our improvement in view consistency. Here we show video sequences from 3D.js and our method, with flip errors as an overlay. As can be seen, our method completely removes popping artifacts. We ran an extensive quantitative performance evaluation. On average, our approach is only 4% slower than 3D.js, with our method outperforming 3D.js for several scenes. This is enabled by several optimizations. Here we will briefly visualize tile-based culling. Please find more information in the full paper. For each Gaussian, we first compute their extent and all tiles touched by the Gaussian. Subsequently, we compute the maximum opacity within each tile. If this is below the predefined opacity threshold, we can discount the Gaussian for this specific tile. Note that we also perform the same optimization for 4x4 subtiles. Here we visualize the number of Gaussians which are considered for each pixel. Tile culling is able to reduce the number of Gaussians effectively. When additionally enabling culling for 4x4 subtiles, the Gaussian count is reduced drastically. We also performed several ablation studies for our approach. We will shortly talk about opacity decay in this video. Our sorted Gaussian splatting algorithm enables a reduction in the number of Gaussians, with similar quality and view consistency. In these circumstances, 3D.js produces even more artifacts. Thank you for listening. Please visit our project page for the code release, the full paper, and even more results.